Greetings everyone. Welcome to our first episode of Junior School Mathematics. Our first topic of discussion is natural numbers. What are natural numbers? As we have it here, natural numbers are counting numbers starting from 1. We have 1, 2, 3, and so on. Classifications of natural numbers. Natural numbers can be classified in two ways. First, even and odd numbers. Even numbers are numbers that can be divisible by 2, while odd numbers are numbers that are not divisible by 2. Examples: we have 2, 4, 6, 8, 10 as examples of even numbers, while 1, 3, 5, 7 are examples of odd numbers. Another way of classifying natural numbers is prime, composite, and unity. Prime numbers are numbers that can only be divided by 1 and itself. Examples: 2, 3, 5. Note that 2 is the only even prime number that we have. 2 is even and also a prime number. On the other hand, composite numbers are numbers that can be divided by a number greater than 1 and the number itself. Example: we have 4. This number can be divided by 1 and itself. But there is another number which is greater than 1 that can divide 4, and that is 2. So this means 4 is not a prime number, it is a composite number. And unity is a number that is not a prime and also not a composite number. Example: 1. 1 is the only unity number that we have because it is not a prime number. Why? 1 doesn't have two factors. The only factor of 1 is what? Is 1. And also not a composite because there is no other number that can divide 1. That means it is neither a prime nor a composite number. The only unity number is 1. We then move on to test of divisibility. A number is divisible by, we have from 2 to 12. We are to show if these numbers are divisible by 2, 3, 4, 5, up to 12 using these divisibility rules. The first number we have is 2016. We want to test if 2016 is divisible by 2. What is the divisibility rule for 2? A number is divisible by 2 if the unit digit is 0, 2, 4, 6, or 8. What is the meaning of unit digit? That is the last digit of the number, which is this. Now we have the unit digit set to be 6. And what we have here is a number is divisible by 2 if the unit digit is 0 or 2 or 4 or 6 or 8. We have this to be 6. That means that it is divisible by 2. Let's test for divisibility of 3. A number is divisible by 3 if the sum of its digits is divisible by 3. What is the meaning of sum of its digits? The digits of 2016 are what? 2 plus 0 plus 1 plus 6. And this is what? 2 plus 0, that is 2, plus 1, 3, plus 6, that is 9. Can 3 divide 9? Yes, 3 can divide 9. That means that 2016 is divisible by 3. For 4, a number is divisible by 4 if the last two digits is divisible by 4. What is the last two digits of 2016? That is 16. Now, can 4 divide 16? Yes, 4 times 4 is 16. That means that 2016 is divisible by 4. Divisibility of 5. If the unit digit is 0 or 5, the unit digit we have here is 6. And that means it is not 0 and it is not 5. That means that 2016 is not divisible by 5. We move on to the next number. Divisibility of 6. If it is divisible by 2 and 3, 2016 is divisible by 2 and also it is divisible by 3. That means that 2016 is divisible by 6. But if it is divisible by 2 and not divisible by 3, it is not divisible by 6. Or if it is divisible by 3 and not divisible by 2, that means it is not divisible by 6. It must be divisible by 2 and 3. For 8, if the last 3 digits is divisible by 8, what is the last 3 digits of 2016? That is 1, 2, 3. The last 3 digits is 016, and this is the same as 16. Can 8 divide 16? Yes, 8 times 2 is 16. That means that 2016 is divisible by 8. 9. If the sum of its digits is divisible by 9, what is the sum of the digits of 2016? 2 plus 0 plus 1 plus 6, which is equals to 9. 9 divides 9. That means 2016 is divisible by 9. 10. If the last digit is 0, what is the last digit here? The last digit here is 6. That means it is not divisible by 0. It's not divisible by 10 because the unit digit is not what? It's not 0. We move on to 11. If the difference of sum of digits at even places and at odd places is divisible by 11, what do we mean by this? We have 2016. This is the first number, second number, third number, and fourth digit rather. This is odd places, and this we have even places. The digits at odd places are what? 2 and 1. 2 plus 1. That is equals to 3. And the digits at even places are what? 0 and 6. We add them together. That is 6. Let's take the difference. 6 minus 3. That is equals to 3. Can 11 divide 3? No, 11 cannot divide 3. That means 2016 is not divisible by 11. And by 12, if it is divisible by 4 and divisible by 3, 2016 is divisible by 3 and also divisible by 4. That means it is divisible by 12. Next example. We have 1650. We start from the divisibility of 2. A number is divisible by 2 if the unit digit is what? 0 or 2 or 4 or 6 or 8. What is the unit digit of 1650? The unit digit is what? 0. And we have 0 here. That means it is divisible by 2. By 3. If the sum of its digits is divisible by 3, the sum of the digits of 1650 is what? 1 plus 6 plus 5 plus 0. That is 712. 3 can divide 12. That means that it is divisible by 3. By 4. If the last 2 digits is divisible by 4, the last 2 digits here is what? 50, which is 50, divided by 4. Can 4 divide 50? No, 4 cannot divide 50 without any remainder. That means this number 1650 is not divisible by 4. By 5. If the unit digit is 0 or 5, the unit digit of 1650 is 0. That means it is divisible by 5. By 6. If it is divisible by 2 and 3, 1650 is divisible by 2 and also divisible by 3. That means it is divisible by 6. 8. If the last 3 digits is divisible by 8, last 3 digits here is 650. Can 8 divide 650? No. That means that 1650 is not divisible by 8. The next number, 9. If the sum of its digits is divisible by The sum of the digits of 1650 is what? 1 plus 6 plus 5 plus 0, and that is 12. Can 9 divide 12? No, 9 cannot divide 12. That means 1650 is not divisible by 9. 10. If the last digit is 0, the last digit we have here is what? Is 0. That means it is divisible by 10. 11. If the difference of the sum of the digits at even places and at odd places is divisible by 11. Now we have this to be 1650. This is the first digit, second digit, third, and fourth odd places. So the digits we have at odd places are what? 1 and 5. If we sum it together, we have 6. And the digits at even places is 2 and 0. If we sum it together, we have 6. Let's take the difference. 6 minus 6, that's 0. Can 11 divide 0? Yes, 11 can divide 0. That means that 1650 is divisible by 11. By 12. If it is divisible by 4 and 3, this is divisible by 3. But it's not divisible by 4. That means it is not divisible by 12. And we'll move on to the next example. We have 964, 32. This number is divisible by 2 because the unit digit is what? Is 2. And we have 2 among the listed numbers here. To test for the divisibility by 3, we are going to sum the digits together first. And that is 9 plus 6 plus 4 plus 3 plus 2. This is 15, 19, 22, 24. We have this to be 24. Can 3 divide 24? Yes, 3 can divide 24. That means this number is divisible by 3. For 4, if the last two digits is divisible by 4, the last two digits we have here is what? 32. Can 4 divide 32? Yes, 4 can divide 32. That means that this number is divisible by 4. 5. If the unit digit is 0 or 5, the unit digit here is 2. That means it is not divisible by 5. 6. If it is divisible by 2 and 3, this number is divisible by 2 and also divisible by 3. That means it is divisible by 6. 8. If the last three digits is divisible by 8, the last three digits here is what? 4, 3, 2. Can 8 divide 432? Yes, 8 can divide 432. That means that 96432 is divisible by 8. 9. If the sum of its digits is divisible by 9, we have the sum of the digits to be what? 24. Can 9 divide 24? No. That means this number is not divisible by 9. 10. It is not divisible by 10 because the unit digit is not 0. 11. Find the difference. If the difference of the sum of the digits at even places and at odd places is divisible by 11, we have 9, 6, 4, 3, 2. First digit, second digit, third, fourth, and fifth. Odd places. That is 9 plus 4 plus 2. And that is what? We have this to be 13. This is 15. What we have next is what? 6 plus 3. And that is 9. 15 minus 9. We are going to have 6. Can 11 divide 6? No, 11 cannot divide 6. That means this number is not divisible by 11. And by 12, it must be divisible by 3 and divisible by 4. The number is divisible by 3, also divisible by 4. That means it is divisible by 12. And the last example. So this number is divisible by 2 because the unit digit is 2 and we have 2 here. Let's test for divisibility by 3. What are we going to do? We take the sum of the digits. 2 plus 2 plus 2 plus 2 plus 2 plus 2. 6, 8, 10, 12. 3 can divide 12. That means the number is divisible by 3. Divisibility by 4. The last two digits. Last two digits here is 22. Can 4 divide 22? No. That means the number is not divisible by 4. Divisibility by 5. If the unit digit is 0 or 5, the unit digit here is 2. That means this number is not divisible by 5. 6. If it is divisible by 2 and 3, the number is divisible by 2 and also divisible by 3. That means it is divisible by 6. And 8, the last three digits. The last three digits here is what? 222. Can 8 divide 222? No, 8 cannot divide this number. That means this number is not divisible by 8. 9. If the sum of the digits is divisible by 9, the sum of the digits is what? 12. Can 9 divide 12? No, this number is not divisible by 9. And 10. The number is not divisible by 10 because the unit digit is not 0. 11. 2, 2, 2. This is the first digit, second, third, fourth, fifth, and sixth. Odd place. That is 2 plus 2 plus 2. That is equals to 6. And even places we have 2 plus 2 plus 2. That is equals to 6. If we take the difference, we are going to have 6 minus 6. That is 0. 11 can divide 0. That means this number is divisible by 11. And the last number is 12. If it is divisible by 4 and 3, this number is divisible by 3, but it is not divisible by 4. That means it is not divisible by 12. We have the first number, which is 2016, to be divisible by 2, 3, 4, 6, 8, 9, 12. The second, which is 1650, to be divisible by 2, 3, 5, 6, 10, 11. And the third, the fourth also. But if you look at this number that we have here, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. One number is omitted, and that is 7. Next is to discuss the divisibility rule of 7. Divisibility by 7. How are we going to know if a number is divisible by 7? A number is divisible by 7 if twice the unit digit is subtracted from the rest of the digits and the remainder is divisible by 7. For example, we have 91. We want to know if 91 is divisible by 7. The rule we have here is what? A number is divisible by 7 if twice the unit digit. What is the unit digit of 91? That is 1. Twice means double. So we are going to have 2 times 1 is equals to 2. Is subtracted from the rest of the digits. The rest of the digits here is what? 9. We are going to subtract 2 from 9. Can 7 divide 7? Yes, 7 can divide 7. That means that 91 is divisible by 7. Next example. We have 875. Twice the unit digit. The unit digit here is 5. Twice, double. That is 2 times 5. This will give us 10. We are going to subtract 10 from the rest of the digits, and that is 87. 87 minus 10 is equals to 77. Can 7 divide 77? Yes, 7 can divide 77. That means 875 is divisible by 7. We have the next example to be 5103. The unit digit here is what? 3. Double 2 times 3 is equals to 6. We will subtract 6 from 510. 510 minus 6. That is equals to 504. This is also a bigger number. Apply the rule again. The unit digit here is what? 4. Double. That is 2 times 4. This is equals to 8. Subtract 8 from the rest of the digits, and that is 50. 50 minus 8. This is equals to 42. Can 7 divide 42? Yes, 7 can divide 42. That means that 5103 is divisible by 7. No, 4. We have 10,003. Unit digit here is what? The unit digit here is 3. Double of it, that is 2 times 3. We are going to subtract 6 from 1,000. 1,000 minus 6, and that is 994. This is a bigger number. We are going to do what? Apply the rule again. The unit digit is 4. Double of it, that is 2 times 4, which is 8. Subtract 8 from the rest of the digits, and that is 99 minus 8. This is equals to 91. Is 91 divisible by 7? Yeah, we have 91 to be divisible by 7. That means that 10,003 is divisible by 7. But if you take note of one thing here, we have this to be 4-digit number, this to be 5-digit number. We have another rule to test if these numbers are divisible by 7, and that is for a bigger number, we make group of 3 digits from right to left. What do we mean by this? Let's apply this second rule to this third example first. This is 5103. 5103. We make what? We make group of 3 digits from the right. 301. This is 3. And this is the middle. Let's take the difference. 103 minus 5. 103 minus 5 will give us what? This is equals to 98. Is 98 divisible by 7? Yes, 98 is divisible by 7. That means that 5103 is divisible by 7 using this second rule. Let's use this second rule for what? For this fourth example. We have 10003. Let's group 3 digits from the right. 1, 2, 3. 1, 2. We have this to be what? The first group to be 10, and the second group to be what? 003. And 003 is the same thing as ordinary 3. Now let's take the difference. The difference is what? 10 minus 3, and that is 7. Can 7 divide 7? Yes, 7 can divide 7. That means that 10003 is divisible by 7. The next number we have here is what? 123 480. If we use the first rule here, we are going to repeat like at least 4 times. But let's go for what? The second rule. What are we going to do? We group 3 digits from the right. 1, 2, 3. 1, 2, 3. What we have here is what? The first group is 1, 2, 3, and the second group is 480. Let's take the difference. 480 minus 1, 2, 3. 0 minus 3 is not possible. Let's borrow 1 from here. This should be 7, and we have this to be 10. We have this to be 7, 5, 3. So now 3, 5, 7. Is 3, 5, 7 divisible by 7? Because what do we have here? After taking the difference, is divisible by 7. Then the original number is divisible by 7. Is 357 divisible by 7? This is also a bigger number. But if we group this in 3, we don't have another number. Let's use what? The first rule. And the first rule is what? Twice the unit digit. What is the unit digit here? That is 7. Twice the unit digit. That is 2 times 7, which is equals to 14. We are going to subtract 14 from the rest of the digits, and that is what? 35. 35 minus 14, and this is 21. Can 7 divide 21? Yes, 7 can divide 21. That means that 1, 2, 3, 4, 80 is divisible by 7. The next example. 381 654 729. We have 381 654 729. Let's group in 3 digits from the right. 1, 2, 3, 1, 2, 3, 1, 2, 3. For a bigger number, we make a group of 3 digits from right to left if the difference of sum of the digits at even places. This is the first group, the second group, and the third group. The numbers we have at odd places are what? 381, odd places, and 729. Let's first of all add these two together. 729 plus 381. This is 0, keep 1, 10, 11, we still keep 1, 10, keep 1 also. We have this to be 1110. And the numbers we have as what? Even places is just only 1, and that is 654. What is the next thing to do? We are going to take the difference of 1110 and 654. And the difference of this is what? Don't let me have it say. 1110 654. 0 minus 4 is not possible. Borrow 1 from here. We have this to be 6. 0 minus 5, not possible. Borrow 1 from here. We have this to be 10, and that is 5. 0 minus 6, not possible. Borrow 1 from here. This will be 10. 10 minus 6, that is 4. Now, what we need to test for is that, is 456 divisible by 7? 456. Is it divisible by 7? This is a bigger number. Let's apply the first rule. Twice the unit digit. The unit digit here is 6. So 2 times 6, this is equals to 12. We are going to subtract 12 from 45. And 45 minus 12 is what? That is 33. Can 7 divide 33? No, 7 cannot divide 33. That means that the original number 381 654 729 is not divisible by 7, because 33 is not divisible by 7. This 21 is divisible by 7. And also this 77 is divisible by 7. 7 is divisible by 7. 91 is divisible by 7. The next topic for today's class is first n natural numbers. What is the meaning of this? We may be asked to find the sum of the first 5 natural numbers. We know that natural numbers start from what? Start from 1. That means the sum of the first 5 natural numbers is 1 plus 2 plus 3 plus 4 plus 5. 1 plus 2, 3 plus 3, 6 plus 4, 10 plus 5, 15. What will be the sum of the first 7 natural numbers? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. 1 plus 2 plus 3 plus 4 plus 5, that is 15. Plus 6, 21. Plus 7, that is 28. But what if we have to find the sum of the first 15 natural numbers? Are we going to use this approach? If we are to find the sum of the first 100 natural number, are we going to use this method? That is why we have this formula given. Sum of the first n natural numbers is n, open bracket of n plus 1, close the bracket, all over 2. What is the value of n? You can see that this is sum of the first 5 natural numbers. And what do we have here? First n. That means for this sum of the first 5, n is equal to 5. And if I'm to find the value of this using the formula, we have n plus 1 over 2. N is equal to 5. 5 open bracket of 5 plus 1 over 2. This is equal to 5 open bracket of 6, close the bracket, all over 2. 2 here 1, 2 here 3. 5 times 3, that is 15, which is the same as what we have here. What of the sum of the first 7 natural numbers? 7 open bracket of 7 plus 1 all over 2. This is 7 open bracket of 8, close the bracket, over 2. 7 times 4, that is 28. This implies that anytime we have to find the sum of the first n natural numbers, we'll be making use of this formula. Example 1. The first example we have here is, what is 1 plus 2 plus 3 plus 4 plus dot 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 plus 15? You can see that this is the sum of numbers starting from 1 and end with what? 15. This is the same as sum of the first 15 natural numbers. And what is the sum of the first n natural numbers using formula? The formula we have here is what? N open bracket of n plus 1 all over 2. What is the value of n? First 15. That means n is equal to 15. Now, 1 plus 2 plus 3 plus dot 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 plus 15 is equal to 15 open bracket of 15 plus 1 over 2. This is equal to 15 open bracket of 15 plus 1, that is 16 over 2. 2 here 1, 2 here 8. What we have next is what? 15 times 8. What is 15 times 8? 8 times 5, that is 40. 8 times 1, 8 plus 4, that is 120. The sum of the first 15 natural numbers is 120. Next example. Find the sum of the first 40 natural numbers. What will be the value of n here? The value of n here is 40. This means that the sum is equals to n plus 1 all over 2. This is 40. 40 plus 1 all over 2. 40 open bracket of 41 over 2. 2 here 1 and 2 here 20. What we are going to have next is what? 20 times 41. 20 times 41, that is 820. Example 3. Sum of first 20 natural numbers. The value of n here is what? The value of n here is 20. And the sum is equals to n open bracket of n plus 1 over 2. This is 20 open bracket of 20 plus 1 over 2. And we have this to be 20 open bracket of 21 close bracket over 2. 2 here 1, 2 here 10. What we are going to have next is 10 times 21. And 10 times 21 is what? 210. What is the sum of first 100 natural numbers? N is what? N is equals to 100. So we have sum is equals to, and this is 100, 100 plus 1 over 2. Two here 1, 2 here 50. We're going to have 50 multiplied by 101. 50 multiplied by 101, that is 5,050. With this explanation, what is the sum of the first 50 natural numbers? And the last topic for today's class is unit digit of a number is the last digit of the number. We are to find the unit digit of the following numbers. Find the unit digits of the sum of 739 and 453. What are we going to do here first? We will first of all add the two numbers together, and that will give us what? 739, 453. 9 plus 3, that is 12. We write 2, keep 1. 3 plus 5, that is 8, plus 1, 9. 7 plus 4, that is 11. Now, what is the unit digit of 1192? The unit digit of 1192 is what? The last digit, and that is 2. But what if we are given like more than 3 numbers to sum together, or more than 3 numbers to multiply together? Are we going to use this method? Another simplified way of finding unit digits is unit digits of 739 plus 453 is the same thing as the unit digit of, what is the unit digit of 739 here? That is 9. Plus, what is the unit digit of 453? That is 3. 9 plus 3, that is what? 12. What is the unit digit of 12? And that is 2. That implies that the unit digit of 739 plus 453 is what? Is 2, which is what we have here. Example 2. Unit digit of 34 times 53 We are going to use the second method. The unit digit of 34 times 53 is what? Is the same as unit digit of, what is the unit digit of 34? That is 4. Times unit digit of 53, that is 3. 4 times 3, that's 12. Now, what is the unit digit of 12? The unit digit of 12 is what? Is 2. That means that unit digit of 34 multiplied by 53 is equals to is 2. The next example we have here is 481. The unit digit of 481 multiplied by 374 is the same as unit digit of, what is the unit digit of 481? That is 1. Multiplied by unit digit of 374, that is 4. And this 4. 1 times 4 will give us 4. This means unit digit of 481 multiplied by 374 is 4. What we have next is unit digit of 704 plus 341 plus 852. The unit digit of the sum of these three numbers is the same as unit digit of, what is the unit digit of 704? That is 4. Plus unit digit of 341, that is 1. Plus unit digit of 852, that is 2. 7 plus 1 plus 2, we have that to, 4 plus 1 plus 2, we have that to be what? 7. You can see that this is a single number. That means the unit digit of 704 plus 341 plus 852 is 7. Next example, we have that to be the unit digit of the multiplication of these four numbers is what? Is the same as unit digit of, what is the unit digit of 207? That is 7. 7 multiplied by unit digit of 781, that is 1. Unit digit of 39, that is 9. And unit digit of 94, that is 4. This is equals to 7 times 1, that is 7, multiplied by 9 times 4, 36. You can see that we have single digits here and we have 2 digits here. I can still take the unit digit of 36, and this is still the same thing as unit digit of 7 times, what is the unit digit of 36? That is 6. 7 times 6, this will give us 42. Now, what is the unit digit of 42? The unit digit of 42 is what? Is 2. That means that unit digit of 207 multiplied by 781 multiplied by 39 multiplied by 94 is 2. With this explanation, What is the unit digit of multiplication of these numbers? Now we move on to the second part. Find the unit digits of the following. We have a 2 raised to the power of 8. We are to find the unit digits of 2 raised to the power of 8. What is 2 raised to the power of 8? 2 to the power of 1, that is 2. 2 to the power of 2, 4. 2 to the power of 3, 8. 2 to the power of 4, 16. 2 raised to the power of 5, 32. To the power of 6, 64. 128. 256. Now the unit digit of 256 is, what is the unit digit of 256? That is 6, what we have here. But what if we are asked to find the unit digit of 2 raised to the power of 50, 2 raised to the power of 75? How are we going to do that? We have to find the unit digit of 2 raised to the power of 8. Is the same as, we will make use of this power. What we have here is what? What we have here is 8. Divide 8 by 4. What are we going to get as the remainder? 8 divided by 4, that is equals to 2 remainder 0. You see that 4 can divide 8 without any remainder. That means we have unit digit of 2 raised to the power of 8 will be the same as unit digit of 2 raised to the power of 4. Since 4 can divide 8 without any remainder, we will write the unit digit of 2 raised to the power of 8 will be the same thing as the unit digit of 2 raised to the power of 4. If we have, let's take for example, we have 2 raised to the power of 7. 7 divided by 4, that is 1 remainder 3. 7 divided by 4, that is 1 remainder 3. We are going to write unit digit of 2 raised to the power of 7 is the same as unit digit of 2 raised to the power of 3, the remainder that we have here. If we have 2 raised to the power of 21, 21 divided by 4, that is 5 remainder 1. The unit digit of 2 raised to the power of 21 will be the same as the unit digit of, this is 5 remainder 1, the remainder 2 raised to the power of 1. But anytime we have 4 divides the number, the power, without any remainder, that means the unit digit of that number will be unit digit of 2 raised to the power of 4. As what we have here, 2 raised to the power of 8. 4 can divide 8 without any remainder. So it will be the same as unit digit of 2 raised to the power of 4. Now, what is 2 raised to the power of 4? 2 raised to the power of 4 is 2 times 2 times 2 times 2. 2 times 2, 4, times 2, 8, times 2, that is 16. What is the unit digit of 16? That is 6. This implies that unit digit of 2 raised to the power of 8 is what? Is 6. And what do we get here? 6. We have the same to be 6. Next example. Now, we have to find the unit digit of 3 raised to the power of 8. The power is what? 8. Is 8 divisible by 4? If you divide this 8 by 4, we are going to get 2 remainder 0. Since the remainder is 0, that means that the unit digit of 3 raised to the power of 4 is the same thing as unit digit of 3 raised to the power of 4. Because 4 can divide 8 without any remainder. Now, what is 3 raised to the power of 4? 3 raised to the power of 4 is what? 3 times 3 times 3 times 3. And that is 3 times 3, 9. 9 times 3, 27. 27 times 3, that is 81. What is the unit digit of 81? That is 1. This implies that unit digit of 3 raised to the power of 8 is 1. Example 3. Unit digit of 5 raised to the power of 3. You can see that this power is not up to 4. That means we are just going to expand this 5 raised to the power of 3. And 5 raised to the power of 3 is what? 5 times 5 times 5. 5 times 5, 25. 25 times 5, that is 125. And the unit digit of 125 is 5. Note one thing. If I have 5 raised to the power of 1, I will have 5. 5 raised to the power of 2, that is 25. 5 raised to the power of 3, 125. 5 raised to the power of 4, 625. What can you notice here? The unit digit is always 5. The unit digit is always 5. That means any positive power of 5, the unit digit of any positive power of 5 is what? Is 5. If you are to find the unit digit of 5 raised to the power of 759, we don't have to stress ourselves. We just write 5. The unit digit is 5. 6 raised to the power of 3. The power here, which is 3, is also not up to what? Not up to 4. We are going to expand. 6 times 6 times 6. 6 times 6, that is 36. 36 times 6, that is 6, 216. What is the unit digit of 216? The unit digit of 216 is what? Is 6. This implies that also notice one thing here. If I have 6 raised to the power of 1, I will have 6. 6 raised to the power of 2, 36. 6 raised to the power of 3, 216. What can you notice? Unit digit is 6, 6, 6. That means unit digit of any positive power of what? Of 6 is also 6. As we have it in case of 5. Now let's take note of this. One raised to power 2, 1. 1 raised to the power of 100, 1. The unit digit of any positive power of 1 is what? Is 1. The unit digit of any positive power of 5 is 5. and any positive power of 6 is what? Is 6. Next example. We are now in what? Example 5. We are to find the unit digit of 14 raised to the power of 12. This is the same as unit digit of what we have here is 14. That is 2-digit number. What is the unit digit of 14? That is 4 raised to the power of 12. This is also the same as unit digits of the power we have here is what? 12. 12 divided by 4, that is 3, remainder 0. Because the remainder is 0, we have 4 raised to the power of 4. Now let's expand. Is 4. 4 raised to the power 2, that's 4 times 2, 16. 4 raised to the power 3, 16 times 4, 64. And 4 raised to the power 4, that is 256. And this is equals to 256. What is the unit digit of 256? That is 6. That means that the unit digit of 14 raised to the power of 12 is 6. Example F. We want to find the unit digit of 17 raised to the power of what? 21. This is the same as unit digit of 17 is 2-digit number. What is the unit digit of 17? That is 7. Now the power. 21 divided by 4. That is 5, remainder 1. We are going to make use of the remainder. That is 7 raised to the power of 1. And 7 raised to the power of 1 is what? That is 7. This means that unit digit of 17 raised to the power of 21 is 7. Next example. (145). Unit digit of 53 raised to the power of 145 times 329 raised to the power of 63 is the same thing as unit digit of 53 is 2-digit number. What is the unit digit of 53? That is 3. 145. Divide this 145 by 4. What are we going to get? 145 divided by 4. What is the divisibility law? Divisibility rule of what? Of 4. Divisibility rule of 4 is a number is divisible by 4 if the last 2 digits is what? Divisible by 4. And the last 2 digits here is what? 45. If we divide this 45 by 4, what are we going to get? That is 11, remainder 1. That means if I also divide 145 by 4, I will have the remainder to be 1. So this one will be 3 raised to the power of 1 times the unit digit of 329 is what? 9. Divide 63 by 4. 63 divided by 4. We are going to have what? The remainder of 3. We will have remainder of 3. This will be the remainder of 3. So this is equals to 3 times 9 times 9, 81. 81 multiplied by 9, that is 729. This is equals to the unit digit of 3 multiplied by unit digit of 729 is what? That is 9. 3 times 7, that is 27. Now, what is the unit digit of 27? The unit digit of 27 is what? Is 7. That means that the unit digit of 53 raised to the power of 145 times 329 raised to the power of 63 is 7. Example H. 19 raised to the power of 119 plus 85 raised to the power of 178 is the same thing as unit digits Nineteen is what? 2 digits. What is the unit digit of 19? That is 9. 110 divided by 4. What are we going to get as remainder? If we divide 110 by 4, what we are going to get as remainder is what? Is 3 plus unit digit of 85, that is 5, raised to the power of 178. Why is it that I don't divide this by 4? It's because the unit digit here is what? 5. And come back to this. Unit digit of any positive power of 5 is what? Is 5. This is equals to unit digit of 9 raised to the power of 3. What is 9 raised to the power of 3? 9 raised to the power of 3 is what? 729 plus 5. 729 plus 5, that is 734. What is the unit digit of 734? The unit digit of 734 is what? Is 4. That means unit digit of 19 raised to the power of 119 plus 85 raised to the power of 178 is 4. Now, with this explanation, what is the unit digit of these numbers? This will be the end of today's class. Thanks for watching. Don't forget to like, share for others to learn, and don't forget to subscribe to our YouTube channel. See you in the next class.